Um, yeah, how was the exam on Friday? Was it difficult? Did everyone do the exam on Friday? Okay. Good to know. Well, how was it different? Different from what? Okay, you probably are saying it's different from the standard exams, but anyway, yeah. Um, okay. So just one reminder. The web work. So all the homework reopened, and they're going to be due on April 27th, Friday, including the last three homework. So the next three homework that we have is 4.4. Is it a Monday? Okay. So including the next three homework, which is the first one is 4.4 and 5.5. Second one is 4.5, and then the last one is 5.1. Today I wanna start a new section 4.4. It should be easy, but it could be a bit confusing depending on how much you remember for what we have done in the last 3 weeks. But let me remind you what we did about integration. So section 4.4 is about net change. And then the first thing I want to talk about is I want to remind you was what this thing means. So by definition, well, we had three definitions of this thing. So this is called the definite integral. Of the function f of x from a to b. I'll explain why it's called definite in a second, but we had three definitions of this thing, this definite integral. The first definition was by using approximation by rectangles. So we approximate this by using rectangles. And let me remind you what this is. So the way you do is you define this to be the sum of areas of rectangles. So let's say you're taking n rectangles, and then you pick your sample points xi, you plug into your function, and then you get this. So for each term in your summation, this is the area of one rectangle. And so when you take the sigma notation, and when you take the summation, this gives you the area of n rectangles. And then when you take the limit, it gives you the exact area. So that the first definition of the integral, of the definite integral from a to b, was the area under the graph from a to b. And then the second definition we saw was using geometry. So it really just It's just the area above the axis minus the area below axis. So depending on what shape you have, geometrically, the integral is just the area above x minus the area below x. And then the last thing we did was algebraic. By algebraic, I really mean the fundamental theorem of calculus. So remember that the first part one of the fundamental theorem of calculus, let's call this one. We had this equals this. And then the second part says that if I want to compute the derivative, if I want to compute the definite integral of f of x from a to b, this would actually be the same as capital F of b minus f of a. And my notation was this guy. So I'm saying that in order to compute the integral, you just need to find the antiderivative. And then you plug in a and b and then subtract. Is it okay so far? This is all just review. Questions? Okay, so the next thing I want to tell you is the indefinite integral. So here's the definition. Given a function f of x, we define the indefinite integral to be the following. So this is a notation for indefinite integral, and I define it to be this guy, where capital F of x is any antiderivative. And c is a constant. I guess I just say this. So it's called indefinite because it doesn't have any, it doesn't have the lower limit and also the upper limit. The integral that we just defined weeks ago, it was called definite because it has the lower limit and the upper limit. That's the only difference. Let me write this down. So if you have lower limit and upper limit, a and b, this is called definite. If there's no lower limit or upper limit, this is called indefinite. That's a difference in the names. But in terms of calculations, what's the difference? So when you compute the definite integral, what do you get? So I'm asking which one is a function, which one is a number? What do you think? So indefinite integral is a function, and definite integral is a number. This is a number. This is the function. By function, I mean it depends on x. Is it okay? So basically, everything that we have done so far are still correct. For example, how do I compute the indefinite integral of this guy? So that means I need to compute the antiderivative of the fourth root of x to the fifth. So let's simplify that. So what is the fourth root of x to the fifth? I can rewrite that as x to the 5/4. And then what is the antiderivative of x to the 5/4? Any ideas? Yep. So the antiderivative should be x to the 5/4 plus 1 divided by 5/4 plus 1. And then don't forget plus c. Questions? I guess we can do this. So how do I compute the integral of 1 plus root x plus x divided by root x? So first, you can split them into 3 terms. And then simplify, and then find the antiderivative separately. So what is 1 over root x? So how do I rewrite that? Okay, so this is x to the negative 1/2. The second term, root x divided by root x, is just 1. And then the last term, x divided by root x, that's x to the 1 minus 1/2. And so the antiderivative of x to the negative 1/2 should be x to the negative 1/2 plus 1 divided by negative 1/2 plus 1. The antiderivative of 1, what is the antiderivative of 1? X. And for the last term, what is the antiderivative of x to the 1/2? It's just x to the 1/2 plus 1 divided by 1/2 plus 1. Don't forget plus c. Questions? Okay. Net change. So net change has to do with this thing right here. So I want to know what is the definite integral of f prime from a to b. So what do you think that's going to be? So in order to compute this, I need to find the antiderivative of f prime of x. What is the antiderivative of f prime of x? It's just f of x. And because I'm computing definite integral, I need to put in a and b. So I guess I should write like this. I need to put in a and b. So this really just means fb minus f of a. Is it okay? Capital F. So I'm taking the integral of f prime, and the antiderivative of the derivative is f itself. Is it okay?
So is that the original like f of x function, or is that an antiderivative? Like the derivative of an antiderivative should just be the function, right?
Okay, so if you want to think like that, my f prime is actually my f in the fundamental theorem of calculus. So no matter how you think, the correct way to think about this definite integral is you want to find the antiderivative of the capital F prime of x. And we know that the antiderivative of capital F prime of x is just the capital F of x, because that's the definition. Is it okay?
So that is equal though, like the lowercase f of x is equal to capital F prime of x.
In this case, yes. I'm not saying yeah, yes. Yes, in this case, yes.
Okay, thank you.
So I'm not doing anything fancy here. So I'm just saying that the definite integral of a function is just the antiderivative. But if you're taking the definite integral of a derivative, it would be just the original function. Okay, so you should think of this f of b minus f of a as the net change in the function f of x from a to b. So this thing right here. Okay. Now let's look at one example. So
Can you go back for a second, please?
yeah.
Thank you.
Okay, so in summary, this is what we have. This is a formula. So the definite integral of f prime of x from a to b is just fb minus fa. Okay, and maybe one quick example is the following. So what is let's say your v of t is your velocity. So what is the integral of the velocity from, let's say, a to b? What does it mean? What does it mean in, I guess, in physics?
Distance b minus distance a.
Yep. So that's a net change. That's a change in distance. From A to B, right? Because finding the definite integral of V of t because the definite integral of the velocity is just a distance function. And then because I'm computing definite integral, you need to plug a and b into your distance function and then subtract. That gives you the change in distance from a to b. And to put it in a fancy way, this is really just a displacement from a to b. Right, the displacement is the same as the change in the distance. Make sense? Questions? Okay. So let's say the velocity of an object is given by this function right here. So t squared minus t minus 6. Now, first part of the question is, I want to find the displacement of the particle of the object from 1 to 4. Second part is find the distance traveled during the period 1 to 4. So for the first part, I want to find a displacement from 1 to 4. So let's say the s function, the distance function is given by s. This is really just saying s4 minus s1, right? The change in distance s4 minus s1. Is it okay? Now, by what we just discussed, this is the definite integral of the derivative of the distance from 1 to 4, right? But then what is the derivative of the distance? So what is s prime of t?
D, the distance? Because speed is the derivative of velocity and speed are the same thing. Yeah, it would be distance, right?
Yep, so the derivative of s of t is just v of t, which is the velocity. So calculating the change in distance from 1 to 4 is the same as calculating the definite integral of the velocity from 1 to 4. And then the velocity function was given in the question, so I want to calculate this thing right here. Make sense? And then the definite integral of t squared minus t minus 6 is t cubed divided by 3 minus t squared divided by 2 minus 6t. And then you need to plug 1 and 4. Is it okay? Questions? So that was the displacement. Second part, find a distance traveled during the same period. So what do I do? Does anyone remember what's the difference between displacement and the distance traveled? So for displacement, you only care about what is your initial position and your final position. For distance travel, you care about where you turn around. So you care about the exact distance that you have actually traveled during the entire period. So how do I find the distance travel? I think we talk about this in the second week or something.
Do you take the derivative of it and then do it?
I take the derivative of what?
The initial function? Like
What
the
do you mean by
derivative of speed? Like the derivative of the speed?
well, okay, so to find the distance travel, you need to look for the points where the object turn around, right? Because, so for example, the object could be moving forward at some during a certain period and then moving backward after a certain period. How do I know when is it moving forward and backward? Which function do you look at?
Velocity to see if it's positive or negative.
Yep. So you look for the points where the velocity is positive and negative. So part B, you need to set the velocity to be 0 first. The velocity was t squared minus t minus 6 equals 0. And that's the same as t minus 3 and t plus 2. And so t equals 3 or t equals negative 2. The time has to be positive though, so this one is not possible, which means t has to be 3. Is it okay? So that means there are two situations. From 1 to 3, the particle could be moving forward, and then from 3 to 4, the particle would be moving backward. So situation 1. The object moves forward from 1 to 3, and it moves backward. From 3 to 4. Situation 2. It's the other way around. So the object could be moving backward in 1 to 3, and then it moves forward in 3 to 4. Is it okay? Questions? Okay, so regardless of what situations we are in, the distance traveled can be computed as follows. So the way you compute is you split your integral into two parts. I mean, your integral should have two parts. The first one is from 1 to 3 of your velocity. And then the second part will be from 3 to 4. This is not it. So in order to make sure that both are positive, I need to put the absolute value on both sides for both terms. Does it make sense? So I'm saying that without the absolute values, one of them would have to be negative, and then the other one has to be positive. I don't care about which one is positive and which one is negative. I just want them both to be positive. So I need to put absolute value separately for both of them. Make sense? Okay. And then just compute as usual. So again, one of them has to be negative, the other one has to be positive, and then I don't care about whether it's positive or negative. So put absolute value for both of them. Questions? Okay. Next example. So consider the function y equals x squared minus 1. Compute the following. So first thing is compute the total area from -1. I guess compute the total area in -1 and 3. So by total area, I mean the physical area. So I don't care about whether it's positive or negative. Second question is compute this definite integral. So I guess I should ask, does everyone understand what's the difference between these two? Are they going to be the same? So remember that the definition, the very first definition, or definite integral was defined to be the total, the area under the graph from a given point, from the lower limit to the upper limit. And then here I give you two questions. So I give you a function, and then I'm asking, first part, what is the total area from -1 to 3? And when I talk about total area, I mean the physical area. The second part, I ask you to compute what is the definite integral of x squared minus 1 from -1 to 3. And then I'm asking you, are they the same? Any ideas? Yep, good point. So total area includes below the graph. Remember, total area includes the below the graph. Yeah. Okay, so for total area, you actually need to look at the graph. And then as I say, you only care about the physical area. You don't care about whether it's above x and below x. That means you will be counting the region below x as positive area for total area. Whereas for the second part, when you're computing the definite integral from -1 to 3, you would be counting the area below x as negative area. Make sense? So for example, for the function x squared minus 1, I need to draw out what's a graph. So what does it look like? What does it look like? X squared minus 1, what does it look like? It's a parabola, and opening upward or downward? It's opening upward. And in general, if I want to draw a parabola, I also need to find out what is the vertex formula, right? Because this is the axis of symmetry. So what is the vertex formula again? You're gonna need that for your homework. So what is the vertex formula? Negative b divided by 2a. And in this case, b is 0. So the vertex formula, so the vertex is just x equals 0. And when x equals 0, y equals -1. So the lowest point would be 0, -1 right here. Make sense? And then you would expect your parabola to look like this. It's opening upward, so it should look like this. Questions? And then I also need to find out what are the intersection points. So what are the intersection points with the x-axis? 1 and -1. So this is 1, -1, this is 1. This is not scaled properly. And remember that I want to compute the total area and also the definite integral from -1 to 3. So let's say 3 is here. Okay, so part A. What is the total area? So you have two regions. You have region 1 from -1 to 1. The second region is from 1 to 3. So what do I do? So how do I find out what is the total area? Okay, so you compute separate, you compute two integrals from the first one from -1 to 1. And you also compute 1 to 3. But one of them would be negative, the other one would be positive. And in this case, the first one would be negative, right? I don't want it to be negative because I don't care about whether it's positive or negative for total area. So you can put absolute value for both of them. Make sense? Is it okay? So if you want, this will be the same as negative from -1 to 3, x squared minus 1 dx plus, no, the area from 1 to 3 I'll answer your question in a second. So these two integrals that I just wrote down here is actually the same as this guy. Does everyone see that? So this is because the second term the second term here is positive, so taking the absolute value doesn't do anything. So it'll be the same as the original function, the original term. For the first term, if you are taking the absolute value, because I already know that the first region is below x, so when you're taking the absolute value, you are making it positive. That's the same as putting an additional negative sign in front of the integral. Make sense? And to answer your question, Ryan, is this the same thing as finding the displacement? No. No. So if x squared minus 1 is your velocity, the first part will be counting the total distance traveled. Ryan, does it make sense? And for Daniel, how do you get the negative sign? Okay, so Daniel, do you agree that without the absolute value, the first term is negative? Do you get that the first term has to be negative? Yeah. And because I don't care about whether it's positive or negative, I'm putting an absolute value. When I'm taking the absolute value of a negative number, for example, -5, what is the absolute value of -5? It's +5. Another way to say this is you need to put an additional negative sign to your -5. So absolute value of -5 is the same as negative of -5. That's what I'm doing. So I'm putting an extra negative sign in front of the integral. Any other questions? All right, so second part. The definite integral of x squared minus 1 from -1 to 3. So for this, I actually care about where is it positive and where is it negative. Wait, let me think about this for a second. So the total area, I don't care about the sign. So yeah, never mind. Sorry. So for the second part, the definite integral of x squared minus 1 from -1 to 3, it will be just computed as usual. So you computed the antiderivative of x squared minus 1, and then you plug in -1 and 3. So this would be just x cubed divided by 3 minus x, and then you plug in -1 and 3. And for people that are interested, so the second part is actually calculating the displacement. So if x squared minus 1 is your velocity, this is the displacement from -1 to 3. Is it okay? Questions? Okay. Okay, so I want to stop here. But before I let you go, I want to take your attendance. So give me 1 second. All right, so any questions before I let you leave? No? All right, I'll see you guys on Wednesday. If you have any questions, feel free to send me emails.